Well, good day, everybody. I'm Jeanette Stewart from Analysis Mason, and I'm delighted that Qualcomm asked me to join this session. I am going to be moderating the session. We're going to be hearing from John, and then there will be a test of 5G mobile millimeter wave, and then there's the opportunity, I believe, to ask questions after that. So just by way of introduction, the topic in this session is expanding 5G to reach its full potential. So John will be running through our presentation, and in the presentation we will be hearing especially about new radio millimeter wave, and we'll also be talking more broadly about 5G expansion, release 16 and 17, and some of the new capabilities that will bring. Just to introduce John, Dr. John Smee is Vice President of Engineering at Qualcomm Technologies. He joined Qualcomm in 2000. So John, I believe that means you have a very extensive history of mobile technologies. So around about 2000, of course, that was just when 3G auctions were being taken place. So you've gone through the full technology cycle, CDMA, EVDO, IEEE, 4G, and now 5G. He has over 75 US patents and has been involved in the system design for a variety of projects. So his work involves taking advanced system designs and signal link processing techniques from theory through to design, standardization, implementation, and through to products. So John, over to you, and I believe that Dan is going to share slides. Excellent, we can see those. So John, I'll now hand over to you for your presentation.
Well, thanks very much for that excellent introduction. And it's truly my pleasure to discuss with the entire audience today, really how we can evolve 5G to make sure it achieves its full potential. And in particular, discussing some of the key opportunities from 5G millimeter wave. Next slide, please. So when we look at mobile communications, it's really important to understand how much the whole technology industry has evolved and the role that cellular communications has played, basically evolving in parallel with that. So if you think of the early days of communications, when we literally had the digital to analog transition, it was really at that point, there was core technologies introduced by Qualcomm. And then the interesting part is the way that communications evolved to fully envelop computing. So we really understand the huge computing capabilities in all of our devices today. And as we look towards 5G, the interesting opportunities are about transforming industries. So not only are we going to continue to better connect people across the globe, but 5G is also intersecting with many new automotive, industrial, smart medicine, huge numbers of other industries. And that's the aspect and the interesting part of 5G as we even look at the spectrum opportunities and we look at the deployment opportunities. It's that interplay between communicating between people and transforming industries. Next slide, please. So when we understand the end-to-end development cycle, we can start with our 5G technology vision. What really is the problem we're trying to solve? What are the requirements we're shooting for? And in a huge period of innovation and invention, when we look at new approaches to bring end-to-end designs across the entire system. One of the things that we've also been spending a lot of time doing is proof of concept demonstrations. We'll show you one of those at the end of today's talk, and it's that ability to deliver end-to-end prototypes ahead of the commercialization cycle. So proving out and testing new designs. Cellular communications has benefited immensely from the global standardization effort. So we consider 3GPP as the huge umbrella organization in which we standardize 5G, and at the same time, there's many other industry bodies and relevant standards organizations enabling a successful global 5G launches. And then the roles of trials is how we test out new technologies on a commercial scale. So we're able to partner with operators and vendors globally to test out new technologies and make sure they're ready for commercialization. So it's truly this virtuous cycle of innovation where Qualcomm has been core through the 3G, 4G, and now 5G, and then beyond evolutions. So it's certainly my pleasure to talk to you today about some of those core 5G millimeter wave applications. Next slide, please. So when we understand the role of spectrum, for this audience in particular, I don't need to introduce the role of low, mid, and high band spectrums, but the interesting thing is how the spectrum here, shown in the center of this slide, to really underscore its central role. So not only do cellular communication systems leverage low, mid, and high bands, but even how they interwork together to offer diverse services. So not only will 5G deliver amazing consumer mobile broadband, it's also going to enable massive Internet of Things and mission critical communications, what we term ultra reliable low latency communications. The other interesting thing about 5G is the deployment. You might have heard things like disaggregated RAN and virtualization and the role of cell densification across frequency bands. So as we look to optimizing cellular systems, one of the core opportunities is making sure that the different topologies can work together. And by topologies, I mean mixture of cell sizes, the role of backhaul, access, front haul, the way in which the radio access network works as the core network. And at the same time, we're able to further improve the cost and capabilities of 5G. If we look at the KPIs that we're shooting for as part of 5G, we're looking for a 10x decrease in latency, 10x increase in experience throughput, spectrum efficiency, traffic capacity, network efficiency. All of these are getting substantially better. And it's this truly core challenge of 5G that we've been working to solve. Next slide, please. So this slide underscores in more particular details the spectrum bands globally. And you can see here the highlighting of the low, mid, and high bands. And so not only do we have the mid-band spectrum, which has been a huge focus in Europe, but also more excitingly, these new millimeter wave bands. And so the millimeter bands globally, we're seeing a lot of interest in the 24 to 28 gigahertz region. And that's one of the reasons where, from a productization standpoint, a global rollout standpoint, we're seeing millimeter wave gain that huge traction. And so the other interesting thing to highlight is the role of licensed, shared, and unlicensed spectrum. It's not only about licensed spectrum deployments. So as we'll talk in some of the further slides, 5GNR as part of release 16 is also enabling operation in unlicensed spectrum. So when we look at the regulatory opportunities and the ability to deploy 5G more broadly, it's not only about deployments in licensed spectrum, and of course, those continue to play the core role in these initial deployments. Next slide, please. So when you look at what's going on with mobile broadband experiences today, it's always challenging to predict into the future. But one of the aspects of 5G is how are we able to deliver even higher data rates? We call them fiber-like speeds. And so we're very familiar with the devices we have today. But the interesting thing is how those devices are evolving, how the role of edge computing is changing how we access information. What are we downloading versus what are we sharing? We're moving to a more immersive multimedia environment. So not only do we have cell phones, tablets, connected laptops, we're also evolving into a world of next generation XR, augmented and virtual reality, new remote experiences. So as we project 5 to 10 years into the future, we do see this continued insatiable demand for cellular communications, and delivering these high data rates is one of the key areas where millimeter wave meets that opportunity head on. Next slide, please. So let's take a look at download speeds. So we're all familiar with running speed tests on our mobile devices. But if we look at, well, what are the interesting numeric considerations for 5G millimeter wave? So here we can have, say, a peak download speed of 2+ gigabits per second. But the interesting thing is the testing that was done to actually show that the average speed is 4x faster, so 4 times faster between sub-6 gigahertz and millimeter wave. And so this ability to deliver, say, 900 megabits per second of average data rate is one of the core applications that's going to enable faster downloads, more responsive web browsing, and it's going to usher in this new area of multimedia communications. Next slide, please. So when we look at the deployment, it's interesting to understand the role of macrocellular deployments. And then we understand the role of picocell deployments in targeted hotspot scenarios. What's interesting also about 5G millimeter wave is the way it can work in venues, how it can go for indoor enterprises. And we look at the role, say, where a huge number of people are gathering, whether it's a stadium, a transportation hub. And so millimeter wave is something that's expanding to indoor public-private networks as well. And so it's not only about adding 5G millimeter wave to the existing LTE cell sites in dense urban areas, it's also about how 5G millimeter wave is going to transform enterprise, how it's going to enable these huge multi-person communication experiences. Next slide, please. So if we understand then the sheer area of delivering the 5G vision, the interesting point is how they all work together. So we have the public networks. We also have fixed wireless access, where we're able to use 5G millimeter wave and 5G sub-6 to offer home broadband experiences. And then we look at the role of private networks. massive IoT, extreme broadband, indoor enterprise, as I mentioned, and then also connecting factories and smart transportation. So truly 5G is about meeting this vision, combining performance across spectrum bands, but then also making sure the network architecture and the communications designs are able to achieve all of these goals, not necessarily exactly at the same time in the same space, but that the 5G system itself can adapt to best serve all of these different use cases. Next slide, please. So when we look at the standardization timeline, we're literally in the process of just completing release 16, and then we've already started release 17. And so 5G, as you may know, began in a release 14 study item and then a release 15 work item. So the specifications from release 15 is what is getting deployed today. And at the same time, this continued evolution from release 15 into 16, 17, and beyond is core to how the cellular ecosystem evolves. And it's that expansion that we've seen in release 16, connecting factories, vehicles, unlicensed spectrum, integrated access and backhaul. And so it's very interesting to see the interplay and the overall system design aspects of 5G. We have the technology aspect, and then we also have to work together globally to ensure the evolution path, the fact that the investments are forward compatible. So we're able to meet many more use cases across time based on this global standardization. Next slide, please. So let's take a deep dive into what's specific in release 16 and 17. So we saw the role of smartphones. I mentioned new devices like XR, and then automotive, connected laptops. So what's interesting also then is this movement into private networks, even 5G broadcast. And then the technologies themselves are continuing to evolve. So if we understand core aspects like MIMO, mobility, power consumption, each of these are getting better as we move from release 15 into 16, 17, and beyond. This is also then enabling us to address new future vertical markets. One of the core reasons for the global investment in 5G is the ability to better serve a larger number of new industries, enabling that transformation that can improve not only worker productivity, but also people's access to information, so we can have a truly more globally connected society. Next slide, please. So let's take a look at specifically unlicensed spectrum. So one of the interesting things in this chart here is the fact that 5G NR enables not only working in an anchored setting, that is where you have licensed spectrum, and then you're working with 5G NR in unlicensed spectrum in a license assisted access approach. But 5G NR release 16 also introduces the ability to operate standalone in 5G NR unlicensed spectrum. That is, you can have the entire network operating solely on unlicensed spectrum. This is truly transformational for the cellular ecosystem because it enables sophisticated cellular algorithms and techniques and equipment to be deployed to best meet new network deployment requirements. So we're able to deploy 5G NR in unlicensed spectrum, meeting these interesting new KPIs that are going to help drive 5G into many more private network and specific applications. Next slide, please. And so if we look now at the role of unlicensed spectrum, and as I mentioned on my earlier slide, unlicensed spectrum is not a phenomenon in one region in the globe. It's something we're both for sub-7 gigahertz bands. So if we look at interesting unlicensed spectrum bands, 5 to 7 gigahertz, and then we also look at the role of unlicensed spectrum in millimeter wave bands, we see this aspect of 57 to 71 gigahertz also showing up. And so the interesting thing here is that unlike the expansion of 5G into unlicensed spectrum, is something that's also core to how 5G millimeter wave can evolve. So the huge amount of bandwidth between 57 and 71 gigahertz delivers huge amount of data rates for some of these interesting new applications. So 5G NR operation in both licensed spectrum and unlicensed spectrum is truly core to unlocking the full potential of 5G. Next slide, please. So when you look at ultra reliable, low latency communication, so the interesting thing with 5G is we're trying to achieve these targeted KPIs. And so that includes data rate, and it also includes latency and reliability. And the challenge truly is achieving these at the same time. You can always achieve reliability at the expense of latency, or very short latencies at the expense of something being truly reliable. So the interesting challenge that was fully tackled by 5G is a design for simultaneous high reliability and low latency. A good example of that is a connected factory of the future. Here we see not only augmented and virtual reality, we also see the role of sensors. the role of creating and sharing data, downloads and uploads. And we understand the specific communication capabilities, the periodicities of these various pieces of equipment. So as we're truly trying to make engineers and employees and the full factory setup more productive, we're also then able to leverage this communication capabilities, the ability to then communicate across a huge number of devices with very differing requirements. So we're reminded of the services triangle where we have mobile broadband, ultra reliable low latency communication, and massive IoT. And so the interesting thing from an industrialization standpoint is a connected factory of the future truly is working on all three vertices of that triangle. Next slide, please. Let's take a deep dive then into the connected transportation framework. So we term Cellular V2X, and it's V2X because it includes vehicle to vehicle, vehicle to infrastructure, where you have smart roadside units, in future use cases like vehicle to pedestrian. So the interesting thing about a truly autonomous and future transportation framework is the way that it all works together. And so we have this improvement in efficiency, road safety, in vehicle experiences. And so the ability to have 5G connectivity, not only in the vehicles, but in also interacting with the global cellular broadband network, enables many new opportunities where whether it's a smart intersection or whether it's improved platooning or multi-vehicle operation. So the interesting thing is the smart city and smart transportation and those global deployments in 5G cellular are also happening at the same time as we're seeing this huge uptake in interest in 5G vehicle communications. There's a reason we have the 5G AA, the Automotive Association, looking at 5G. And there's a reason that 5GNR Release 16 includes V2X as one of its core capabilities. So 5G is truly not only connecting consumer mobile broadband, but also the transportation ecosystem. And here we see a very interesting future opportunities as this continues to evolve over time. We've seen huge transformation happening in transport. And so the interesting thing is as we look at vehicles of the future and the value proposition for fleets, consumers, then 5G connected infrastructure enables that smart transportation fabric of the future. Next slide, please. So here we do a look at the virtual telepresence. So we all understand, particularly now more than ever, collaborating with our colleagues and others via virtual meetings. So the interesting thing, what about virtual telepresence? Where you're truly able to leverage not only the human-computer interface evolution of connected smart glasses, but you're also able to have access like edge compute, where the storage, the processing of that information is more local, it's lower latency. So all of a sudden I can have more collaborative multi-person experiences. This example here shows two people co-designing something, and even though they don't have to be physically in the same room. So the ability to collaborate, not only within your organization or across organizations, but truly across boundaries. And so one of the interesting things with 5G is the evolution of edge compute, the evolution of cloud compute, the evolution of augmented and virtual realities. All of those are intersecting the evolution of core telecommunications. It's the reason that 5G itself, even as part of Release 17, has a specific study item on augmented and virtual reality. So recognizing the evolution on the device side, the evolution on the compute and communication and storage side is also core to how 5G enables this transformation. So this is a great example of where we could be doing 10 years from now. And then how soon we can do it will be dependent on how quickly 5G technologies get deployed. Next slide, please. So here we're showcasing the fact that you may recall that 4G LTE began in Release 8. And then there was Release 8, 9, 10, 11, 12, 13. So that was 6 or 7 releases, each about 1.5 years long. As we look to 5G itself, we can also expect that continued evolution from Release 15, 16, 17 into 18, 19, 20 and beyond. At the same time, we're already beginning 6G research. 6G is coming. Of course, it's about 10 years away. At the same time, it is absolutely the time for core, deep research in this area. So not only collaborating across industry and academia, but then also looking at long-term new applications. What are the longer technology vectors? The role of machine learning and artificial intelligence in smart networks and smart device and smart edge compute. So there's many new areas of research that are happening as part of 6G. At the same time, 5G evolution has a huge roadmap still ahead. And that's the reason we're very excited about what's going to be coming in Release 17, 18, 19, and beyond. Next slide, please. So we can now, if you click, we can now begin the demonstration of our millimeter video.
Network in a headquarters in San Diego for a number of years now to push the technological boundaries of 5G. This is a 28 gigahertz system that represents a real-life deployment and allows us to understand and address real-life deployment issues. This was a network we showcased last year in MWC 19, but have since further enhanced to provide more robustness and coverage. It's a single cell deployment, single GNOB with multiple distributed remote radio heads that provide receive and transmit diversity, as well as fast beam switching across the deployment space. We've also enhanced it with repeaters, Qualcomm prototype repeaters, for non-line of sight coverage and out-to-in coverage. The test device on our network is based on a Qualcomm Snapdragon 5G modem RF system. We have 3 antenna modules for uniform coverage and experience for the UE. Throughout this demo, you'll be seeing this GUI that portrays the KPIs for the demos. We have the downlink throughput, the active and candid beams for up to 2 remote radio heads on the GNOB, as well as the active module and the associated beam pattern for the device. We'll be covering robust mobility, enhanced deployment, as well as new use cases on our network. With distributed remote radio heads, the GNOB has the ability to use multiple remote radio heads to different users or to a single user. We'll start off by showing the capability of spatial multiplexing. So using 2 remote radio heads to support 2 relatively close users without any interference to each other. We can also use these multiple remote radio heads to provide extra robustness as well as coverage for a single user. In this demo, we have a single user, again, being covered by 2 remote radio heads, walking towards a courtyard and briefly blocked by a metal van, but without any cut to service because of the other remote radio head. So this level of robustness is exactly what you would need in a real-life deployment, especially when you have a dense number of users or dynamics in the environment, such as in a big square like Times Square. So in this next demo, we'll have a user, again, being served by 2 remote radio heads, the same 2 remote radio heads, walking through a large crowd, dense crowd, and being periodically blocked from either side, but able to maintain the link and able to maintain the experience because of the multiple remote radio heads and the multiple antenna modules on the UE. We also want to show the limits of Release 15 as well as our own beam management algorithms. So the ability to beam switch and beam track our device. We put our device on a drone to have high mobility across our deployment area, as well as show high dynamics by showing rotation of the drone. We saw that even with a single remote radio head, we're able to comfortably support high mobility as well as the dynamics for, again, a uniform experience in the deployment. As we know, millimeter wave, it's hard to get non-line of sight coverage unless you have good reflectors in the space. So you're bound to have coverage holes in your deployment. We show that with our prototype repeater, that we can actually overcome this line of sight diffraction loss and provide coverage and extend the coverage area. So repeaters are not only good for overcoming the diffraction loss of going around buildings, but also to overcome penetration loss going from outdoors to indoors. This would be key to provide any kind of coverage in an indoor space, lobby, cafe, or store where you have a high density of users and you want to provide data offload. We've also used our network to test new use cases such as boundless VR extensively to see that we can support the performance needed. We know that millimeter wave systems in terms of throughput and latency are perfect for these type of applications. But we also show that in our new deployment strategy with multiple remote radio heads, we can provide a level of robustness that are key for these immersive experiences. Thank you.
Oh, that concludes the video. So I think, Janet, we should probably move to the Q&A session.
Yes, let's do that. So thank you very much, John. That was really fascinating. A lot of future opportunity and insight there. Just before we look at any questions from the audience, just one question from me then. So Release 16 and Release 17, the timetable is fairly clearly set out in your slides, from the 3GPP perspective. How quickly do you think we will start to see these technologies being deployed, in the market? So starting with 16 and then 17.
No, that's a great question, because we see the approximate cadence, as I mentioned, for standardization is around 15 to 18 months. And then if we look at the timeline between when the standard completes to when technologies get deployed, it could be about a year and a half or so. It really depends on how jump-started the ecosystem is. And I kind of mentioned that's one of the core role that my research team plays, is where we're actually working ahead of the time with these trials. So as we're working with the global infrastructure community and the operator community on the new launches, we're able to actually test the materials as they're being standardized, so that when the standardization is complete, at that point, it's really more the true finalization, the basically dotting the I's and crossing the T's of all the specific language in the specification, but the core capabilities of that standard are well understood throughout its evolution path. And so that's one of the interesting things that enables then the faster uptake of technology, is that once the standard is complete, it's not at that point that the industry begins understanding the capabilities of it. It's actually happening in some cases ahead of the standardization and in parallel with it, such that then the semiconductor roadmap, the software upgrade cycle on the network side, those are the techniques that end up defining the true timeline. And so we see then this aspect of about a year and a half or so, and it can vary. Sometimes it can be 1 year, sometimes it can be 2 years, depending on the particular technology component. And so we see that early planning already for what's coming in release 17. We're having those discussions now, even though release 16 technology is just finished. And of course, we've been working on release 16 for many years now. And so one of the core benefits of the cellular telecommunications industry is how there is this global NRE cycle, this global collaboration and interworking, so that the technologies as they're deployed, we're already aware of all of the IODT issues, the ability to quickly deploy it, because we've worked with the global infrastructure vendor, OEM, device community. So that's a very good question. And it's one of the reasons that we see that expansion of 5G also involving many other industries participating directly in standardization, participating directly in industry groups, whether it's for automotive, like 5G AA, or smart factory, like 5G ACIA.
Good. I mean, that was actually one of my other questions to do with this sort of participation. I mean, one of the really interesting aspects of release 16 that you mentioned is this new radio in unlicensed. So, as you were saying, sort of 15 to 18 months before we start to see deployment. So 2020, we might start to see deployment in 2022. I just wondered, in terms of the participation in the development of NR and unlicensed up to this point, are you confident that we will see a sort of widespread deployment? Is there a strong sort of interest in deploying it?
No. So when we look at NRU, one of the interesting things is that not only do we see the opportunities for licensed spectrum holders, that is, MNOs, mobile network operators, who can leverage millimeter wave and sub 6 gigahertz, not only for commercial deployments, say on licensed spectrum, but they can also pair that with unlicensed spectrum deployments. And so you have this ability not only for the existing operators to add unlicensed spectrum, but then also this 5G and R standalone. And so to your question on the timeline, what's interesting, we see both the opportunities for licensed spectrum holders, but then also the opportunity for NRU to really enable these new private network deployments. So deployments, whether it's in a factory where you might not have spectrum allocated, or whether it's in a smart school or a campus of the future. And so the 5G technologies, whether it's on the network side, new techniques like network slicing, the ability to have a light 5G core, how that interacts with these new RAN topologies. So 5G NRU enables the full access of that technology also into a lot of these interesting private network and enterprise scenarios.
Yeah, and I mean, just in terms of the awareness of the tech itself, do you think, have you had participation in 3GPP from, that community, the enterprise? I mean, you mentioned 5G AA as a good example of a vertical, but presumably there's many others that, this technology could be deployed in.
Right, and then that's the interesting thing when we look at the kind of the defining characteristic G to G. So that's something, Qualcomm's in the G business, as we like to say. And so we really do pay a huge amount of attention to that. And hence this aspect of, the very early cell phones. We understand, the role of CDMA in the early days, the role of, moving to digital communications. And then when we look at the 4G to 5G transformation, that's exactly the interesting part, the sheer number of verticals that are interested in 5G. So there's companies that we're working with today where we would not have had a discussion 10 years ago. They thought, oh yeah, that's, telecom, I'll make sure my employees have smartphones, and that's about it. Whereas nowadays we see that enterprise productivity, we see that as a wide range of industries are looking at investments and their need to stay competitive and their need to make sure that they have that flexibility, that upgrade capability. They want to make sure that they're leveraging the 5G technology curve as well. And so that's the aspect, as you mentioned, not only connected vehicles and connected smart transportation and factories, but then also many new medical companies are reaching out to Qualcomm. We're having interesting discussions on the hospital of the future, opportunities for where education is going. And education, as we understand, right now we're in an environment of huge amounts of distance-based education, but then also from an overall training standpoint, the ability to have information shared much more broadly, then how does that end up impacting the global education system? And then the ability to leverage new technologies like augmented and virtual reality, all of a sudden you start having virtual teacher presence. And so you have these new industries that, and even existing, long-term operating scenarios where, cellular was just, happening in parallel, whereas now it's happening in a much more integrated framework. And that's one of the things that's enabling then just 5G expansion is these other opportunities, these other vertical markets are engaging with the telecommunications industry much earlier in the process because they actually want to understand it. And then we work together to say, hey, how can we best meet your current needs? But more importantly, how can we work together to identify your future needs and ensure that the technology roadmap is well aligned to your goals?
Okay, thank you. That's very interesting. I'm just seeing if there's any more questions. One question, just going back to the millimeter wave in particular, and you discussed this at the start of the presentation, and then we had the demonstration there. Do you have any thoughts then on European deployment of millimeter wave? Obviously, in the US, you're a bit ahead of the curve there. How do you see this playing out in Europe? How extensively will it be deployed, and where do you think some of the different deployment scenarios might end up, sort of outdoor, indoor, etc.?
Right. So that's the interesting part, that absolutely we saw the US moving early on millimeter wave. At the same time, we've been working at Qualcomm across all of the constituent countries. And then we look at the European Union and the role of the spectrum auction. So when we look at 26 gigahertz and the opportunities, 27 gigahertz, the opportunities across countries, we are now seeing significant investment and interest from the operators because they're saying, hey, I understand exactly what I have with 5G sub-6. I understand how much bandwidth I have. I understand how to deploy that, leveraging my LTE cell sites using, for mid-band massive MIMO as an example, or pairing that with low frequency 600, 700 megahertz. And so the interesting thing now is that the operators are now strongly making all their plans, and there have been commercial announcements, if you see the material, of 5G millimeter wave in Europe. And it's because they see that immersive mobile broadband. It's truly transformative in terms of how people consume data and even what they share. So it is always this virtuous cycle of, what people do with technology depends on the technology capabilities. And so the technology capabilities of millimeter wave transform how people use, share, create, store data. So the role of edge compute, the role of what is stored in what part of the network, what is stored in terms of computing, in terms of cloud computing. It's not all about central processing in a cloud. There's a desire for more edge cloud communications. And so that's a great example where as industries and regions are looking at, hey, how can we make sure that we're doing everything we can from an economic development standpoint to have widespread societal transformation, then they see 5G millimeter wave as one of those core enabling technologies because it better connects not only their citizens, but also then as they see the industry development, as they see that investment cycle. And so 5G millimeter wave in Europe is absolutely happening. And then we're working with operators across the region to work on all the timelines, the spectrum auctions. The Qualcomm, European team is hugely involved in the specifics on a per country basis of where spectrum is going, all of the rules to ensure effective operation of millimeter wave. So we're really excited about what we're seeing millimeter wave in the deployments that already exist. And at the same time, we're very excited about how operators are now seeing that huge potential and making those deployment plans.
Great, thank you. I just wonder, any other questions? So there is some feedback. Please feedback to John that his presentation was excellent. A big thank you from the audience. So thank you, John, for that.
You're welcome.
I believe your slides will be made available. Is that
Yes,
true?
they will be.
Yes.
Yeah.
Lovely. Okay. So any other questions before we wrap up? Or John, any final comments from you?
No, I just want to really thank the entire organization for enabling this talk today. And we're really excited about where 5G is today. And even though this event was virtual, it's always great to connect on video and have questions and advanced Q&A, something where we're able to more interactively engage despite the fact that we're not traveling. So I think communications is only going to be more and more a part of our future. Again, for this great opportunity.